All right, this is chapter 6, test review. I'll go through like the first 10 problems. It says the square root of 800 minus the square root of 72. Remember, with the square root of 800, you have to simplify it. Up here at the top, it asks for the perfect squares between 1 and 25. Guys, it is beneficial to you that you can recognize the square root of 400 as a perfect square. What's the square root of 400? 20. So I changed the square root of 800 to the square root of 20 times the square root of 2. So now I have to simplify the square root of 72. 72 concerns me. And the reason 72 concerns me is a lot of us would go to 9 times 8. And guys, if you went to 9 times 8, I understand why you did it. But guys, that would be a little bit of a mistake because the square root of 8 can be simplified to 2 and the square root of 2. You have to make sure you find the largest perfect square that goes into 72. The largest perfect square that goes into 72 is 36. Now, sitting in this room, there's somebody that might not recognize 36, and you kept going on down like this. You kept doing your prime factorization. Remember what she said to simplify these radicals is you circle 1, cross 1 out, circle 1, cross 1 out. I can't circle the middle 2 right there because there's not something to cross out. So back in the very beginning, I said 2 and 36. What's the square root of 36? So I got minus 6 on the square root of 2. Now again, that's when we were going through when we first learned about these, we said you treat these just like terms. If sitting in the class today, I say, what's 20x minus 6x? Every single one of you would go 14x. You get it right. What I'm trying to get you to see is this is the same type problem. What's 20 on the square root of 2 minus 6 on the square root of 2? That's right, 14 on the square root of 2. Okay, so what I have is, in number 3, I have several things that need to be simplified. The square root of 2 has a coefficient of what? Has a coefficient of what? 1, yeah. There's a 1 there. Because 1 times the square root of 2 is square root of 2, so it doesn't change anything. So I got 1 plus 4 on the square root of 2 minus 5 on the square root of 2. Again, guys, what you're not seeing right now is I look at the square root of 32 and I know what the prime factorization of the square root of 32 is. If you don't recognize the prime factorization of the square root of 32, is write it out. Go all the way down to all your prime factors. Circle 1, cross 1 out, circle 1, cross 1 out. That's where 4 on the square root of 2 comes from. What's 25 times 2? 50. What's significant about 25? The square root of it is 5. So I got 1 on the square root of 2 plus 4 on the square root of 2 is 5 on the square root of 2. 5 on the square root of 2 minus 5 on the square root of 2. Is that what it is? It's 0. $980. There's no magic here. There's nothing. I keep saying that because I think some of you think these problems, I'm going to say, hey, don't forget to simplify that one. You don't say anything. You've got to know to take 980 and try to write the prime factorization of it. I know 2 goes into 980 because it's an even number. So I go 490. 2 goes in there again. 245. Okay, so now what would go into 245? I guess 5. 5 goes into 245 49 times. So 7 and 7. We okay? Circle 1, cross 1 out. Circle the 5? No, why don't I circle the 5? There's nothing to cross out. Circle 1, cross 1 out. 2 times 7 is 14 on the square root of 5. I changed the square root of 980 to 14 on the square root of 5. So now I have 3 times the square root of 245. I already recognize here because from where I did it right there, from here down is 245. So that's 7. That's 7 on the square root of 5. So I got 14 on the square root of 5 plus 21 on the square root of 5, 35 on the square root of 5. Guys, you want to check it? Take your calculator and write square root of 980 plus 3 times 2 on the square root of 45. Hit enter. Take your calculator and do 35 on the square root of 5. 35 times the square root of 5 will give me the same thing as this right here. If I start out with plug that into the calculator and I plug this into the calculator, it'll be the same value. Just like if I put what? 14/28 into a calculator. If I put 14/28 into a calculator, what would it say? 1/2. What would your calculator say there? 0.5. That's right. It's not going to say 0.5. Guys, this is just the Algebra 1 version of reducing something. Is you're simplifying a radical. Square root of 169, do you recognize it? Say it, 13. So 7 times 13 minus 18, 324, recognize it? – 16 times 16 is 256, 17 times 17 is 17 times 17 is 289. 18 times 18 is 24. So 7 times, let's take your calculator, figure out what 7 times 13. $91 minus 324. Negative 233. Simplifying radicals. All right. These two are two very different problems now. They both use the distance formula. But what you got to understand is where you plug the numbers in at. As it doesn't matter where you start out in the distance formula. What you got to notice is what number it is that it's asking you to find. We haven't seen a lot of this one right here. Okay, it's in this problem, you just take your x1 and your x2 and plug it in. So x1 is -3, x2 is 14, y1 is -7, y2. First step, substitute. Second step is you add or subtract. So this gives me -17 squared plus -6 squared. This step concerns me because I can't see everybody's paper all at once, guys. You got to remember, -17 squared is going to end up being what kind of number? Positive. If you take a calculator and you say -17 squared like that right there, without the parentheses, if you type that right there in without the parentheses, your calculator is going to give you a negative answer. That's not what's intended right here. What's intended right here is that you take -17 and you multiply -17 times -17. Well, two negatives make a positive and you end up with positive 289. So you got to make sure here you get positive 289 plus 36. What is that? Square root of 325. Again, I'm not looking for you to run to your calculator and punch a button. I want you to take and figure out whether or not 325 simplifies. And the way you see whether or not it simplifies is you see if there are any prime factors of it. I know 5 goes in because it ends in a 5. So 5 goes in there 62 times. Oh yeah, I'm sorry. 5 goes in there 65 times. 5 goes in there 13 times. 2 5s and a 13. If I wanted to check it, and I plugged 5 on the square root of 3, or excuse me, if I plugged the square root of 325 into my calculator, it would give me a decimal answer. Let's see if we can kind of figure out what the decimal answer would be. 18 times 18 is 324. 19 times 19 is 361. 20, so somewhere between 18 and 19. If you think about it for a second, 18 times 18 is 324. Then 1 more makes 325. So I bet it's 18.0 something even. So if I rounded it off, I'd get 18.0277. So I could say 03. Now, what should happen when I do 5 times the square root of 13? Do it. Take your calculator, 5 square root 13, enter, bang, same thing. The reason it's the same thing is because you've taken this difficult number and you simplified it. This is the answer that we're looking for. Just like in circle problems, guys, just like in a circle problem, you want to write your answers in terms of pi. You want to write your answer in terms of pi. With square roots, you want to write your answer in a simplified version. Now watch. Start out, d equals square root of x1 minus x2 squared plus y1 minus y2 squared. The same exact way, but this time, look what it says. This time it tells us d is the square root of 34. So I got to put the square root of 34 there. What I'm looking for in this problem is figuring out x1 minus x2 squared plus y1 minus y2 squared. So b plus 1 squared is right there. Now, look at this problem. Let's take a close look at this problem. It's got square roots in it. If I want to get rid of a square root, I square something. So what I'm going to do is I'm going to square both sides. When I square both sides, that gives me 34. Square root of 34 squared is 34. Over here on this side, that would give me 6 minus 3 squared is 9. So that's equal to 9 plus b plus 1 squared. Again, where did the square roots go? It went away because I took the square root of it, or I squared it. So now subtract 9. What's 34 minus 9? So 25 equals b plus 1 squared. B plus 1 squared. I got a squared. How do I get rid of a square root? How do I get rid of a square root here? Squared it. How do I get rid of a squared over here? Square rooted. Need to take a close look at this because there's 2 possible solutions. You got to think about what I've done here. The 2 possible solutions are 4 and negative 6. The reason I said 4 and negative 6 is today, sitting here right now, if I told you two things multiplied together and gave me 25, two things multiplied together give 25, you think 5. But it could be negative 5 too. You don't know. Because 2 negative 5s is a positive 25 as well. So right here, when I took the square root of this, I had to work b plus 1 equals 5, because 5 times 5, and I had to work b plus 1 equals negative 5. Negative 5 times negative 5. So the number, watch, this is why I showed you that problem yesterday, 4 and negative 6. You can plug either number in. Remember yesterday I did the number above it and below it, and I said notice that both of these numbers work. I can either put a 4 right there, and this gives me 5 squared, or I can put a negative 6 in for d. Negative 6 plus 1 is negative 5, be the same thing. So guys, this problem has two possible solutions. It's either 4 or negative 6. What I want you to see, guys, it's a distance. Don't get confused with this concept. It's a distance formula problem. So the first thing that you ought to do, guys, is write the distance formula. I keep going back to this concept when we work distance formula problems, when we work Pythagorean theorem problems. Guys, the first step is you just substitute stuff in. So the first thing I did was I read the problem and I plugged in the 34. I plugged in 34 for d. Excuse me, square root of 34 for d. I plugged in 6 plus b, 6 for x, b for y. 3 for x, negative 1 for y. And it's just a matter of keeping up with your signs. Find the midpoint. Not a problem. Add the x's. Divide by 2. Add the y's. Divide by 2. Good final answer? Negative 5.5 and positive 5. This is very, you can't not try these, because the first time you don't try it, you don't see the difference between number 8 and 9. Because remember, 8 and 9 are almost opposite of each other. Because in number 8, you have the endpoints. In number 9, you have the midpoint. So 3 equals some number plus negative 4 divided by 2. Look, negative 4 equals some number plus 10, plus a negative 10, minus 10. Now, the thing that I would do is make sure when you get finished to go back and check it. Multiply by 2, 6 equals x minus 4. So what's x? 10. If x is 10, watch. X is 10. 10 plus negative 4, 6. 6 divided by 2. Look, it works. The midpoint is 3. Here, negative 8 equals y minus 10. Add 10, and you get y equals 2. If y is 2, 2 plus negative 10 is negative 8. Negative 8 divided by 2 is, look, negative 4. Guys, it works. This endpoint right here and the endpoint 2, 10 gives you 3 negative 4 as its midpoint. Now, why is it in this problem I didn't get 2 answers? But in the last problem with distance formula, I got 2 answers. What's different about the midpoint formula that's not in the distance formula, or vice versa? What happens in the midpoint formula? x1 minus x2 squared. When you do x1 minus x2 squared, guys, that gives you the possibility for 2 solutions. again, sitting here right now, if I ask you the square root of 36, guys, I understand why you just go 6. But it's negative 6 as well. 36 is either 6 times 6 or negative 6 times negative 6. It could start out as either number. So in the distance formula, you have to account for those. In the midpoint formula, you don't have to account for them because the midpoint is add the x's divided by 2, add the y's divided by 2. Horizontal, or slope of a vertical line is undefined. Slope of a horizontal line is zero slope. Remember when you find, in number 12, when you find the slope of a line, don't forget that y goes on top.